He's a physicist and mathematician and is very interested in natural philosophy and apologetics. He graduated with his bachelor's and master's degree from USF, where he researched molecular dynamics simulations. After graduation, he began working as a secondary educator in Florida, and he joined SEU's faculty in 2019. This semester, Professor Almand has been completing a series of talks exploring Einstein's theory of relativity. It is my great honor to introduce you to Professor Matt Almand.
Wow, this was so unexpected. I don't know if I have anything prepared, but we'll see what we can do. All right, I hope everybody's doing well today. I'd like to thank everybody for coming out and giving me a chance just to kind of talk about one of my favorite subjects again. I also want to thank my wife who fixed up my PowerPoint for me because it was pretty plain and boring when I made it. She jazzed it up for me, so good for her. And also God for giving us the opportunity to come here and have a day to learn and better ourselves all for His glory. All right, so let's go ahead and get going. I want to talk about the philosophy of science, and at first I thought, well, maybe I'm just going to talk about it in general, but realized I should probably really focus it in that this is a physicist's view on it. Okay, so it's not so much the emergent sciences, it's more the foundational, like lowest level type things you can get to, which it tends to be what the physicists deal with. And so if I say something that's horribly off with the biologists or the chemists, feel free to let me know, we'll discuss it, it'll be great. Okay, so we want to start off talking about the fundamentals of science, then we're going to move on to talking about models in science, and then we're going to talk about the assumptions in science and the big assumption in science. All right, so this one was one that prior to coming to here, I would have made this slide just about correlation. But there's a certain Dr. Horton here who has convinced me.
I'm here.
Oh, there you are. Who had a wonderful, spirited discussion with me, as many that we do have, that observation should be the fundamental thing. And I've thought very long and hard about it, and I've decided that observations we can't do without correlations, because then we're just looking at a bunch of randomness, and that we can't really, there's nothing to observe without correlations. Maybe we wouldn't even be here. So I made it basically correlation and observation, or the observation of correlation. All right? And that's the main thing we are wanting to look at. That's what happens in science. You essentially look at event A, and then you find that every time event A happens, event B happens afterwards. And if that is the case, you start to decide that they are causally linked, or at least potentially causally linked, that A causes B. For example, if I were to walk in front of a building and this building were to collapse, right, I wouldn't then go ahead and assume that my walking in front of buildings makes them collapse. I would have to build a correlation. I would have to start walking in front of the next building and see if it collapses. And then the next after that. And even if I did walk in front of the first building and it collapsed, and then I walked in front of the second building and it collapsed, or the third or the fourth, and they kept collapsing, I am still just building up a correlation. And correlation does not necessarily mean causation. It could be coincidence. Perhaps I happened to be on a street where they were demolishing a bunch of buildings to build a mall. So there could be hidden things there that I don't necessarily know about that we may discover down the line. The only way to really be, I would say, 100% sure that your correlation was a causation was to exhaust every single possibility. I would have to walk in front of every building that has ever existed, or ever could exist, or does exist right now, and they would all have to collapse. Otherwise, there is still, it might be a very small chance, there is still a chance that that is just wrong. Okay? It may not be super significant, but it's still there. Okay? Now we're going to get on to models. Okay? This is basically what happens, and all of my pictures have disappeared, and I'm not sure why, so I apologize. But pretend there was a nice picture of rocks right there. So we're going to talk about a black box. We come across a black box, And all it is, we can't open it up, we can't see inside it, but there's a hole where you can drop something in and then a hole where something else comes out. And we want to figure out what's inside this black box. So the first thing we do is we drop in, say, a big rock. And out comes, out of the bottom, we get a bunch of little rocks. So we think, well, maybe there's some sort of grinder in there or some sort of blender type rotor in there that's crushing them up. Okay, because they were pretty jagged or whatever. And so we make that as our model. This is what's happening. And so then we move on and we test that model. We go to the next thing, we say, all right, that's our model, let's try it now on an ice cube. So we drop in an ice cube, expecting that we're gonna get broken chunks of ice coming out, but we don't. Say instead we get drops of water coming out. So now at this point we have to adjust our model, because just some sort of chopping mechanism or some sort of grinder there is not gonna necessarily account for the water in that amount of time. Maybe it has to be something that's heated. Maybe it has to be crisscross lasers in there that are cutting stuff. I mean, I don't know yet, right? So I adjust my model and I try to make it fit with the data that I now have. After that, I go on and I test it again. So now this time maybe I drop in a piece of bread and it comes out toasted. And it comes out in little chunks. And I think, great, this works. My idea of these heated blades that cut things up like this and also do this, that fits, that predicts what's there, right? And so you keep going like this. You make a model and you see how well it makes predictions. If it makes good predictions and it's useful, you keep it. If it's not, you adjust it. Now the question here becomes, how long do we go with a given model, making adjustments to it until we maybe realize that we were way off from the beginning? Like maybe I only ever stuck with the idea that we just had some sort of spinning blade in there that was heated, when it turns out that maybe, like the crisscross lasers, would have worked better. So at what point do I stop trying to just keep adjusting my model and rather step back and go back to the beginning and start over? Is there a point where you reach that? Sometimes that has happened and we've had great revolutions in science because of that, instead of just trying to fix what we have. And so that's a very tough one to know, I would say. When do you ever go back and start over and lose all that work? The second question then about models is, do they actually describe reality? All right, we have these models, they work for us, they give us nice, testable predictions, they're useful, we can make cars, we can make cell phones, we can do all kinds of stuff with them. But how do we know if it's actually telling us what's going on, instead of just being a useful tool? All right, I'm going to use Richard Feynman's example here. I'm going to try and give credit for all my examples where I can, if I remember where I got them. Otherwise, they either were my own or I just forgot where I got them. So Richard Feynman talked about this one, where he said, and there was a nice picture of some mountains here with a setting sun, so just imagine it, okay? It was really nice. It was right there on that side. So he said that what if you started with a jar that was full of beans and a jar that was empty? And you looked the first day and you saw the sun go down over a certain peak of a mountain. And then every day you watched it set, and it didn't set over top of that mountain, you'd move a bean to the other jar. And you kept doing this until the sun eventually set right on top of that peak again. And then you could look and count up beans. And now you have a tool right there that is perfectly useful for predicting where the sun is going to set. All right, it's useful, it works. Every time you do it, you get to that same number of beans, there it goes, right down over the top of that mountain. Right, it has a strong correlation. But does anybody actually think that the beans have anything to do with where the sun sets? Does it really matter? If it's useful to us, right? It may not be as useful as a different model, say, talking about, stellar dynamics, Newton's law of gravity, general relativity, those things. They might give us more use, but it's still useful. And then how do we know whether or not anything we're doing actually is telling us what's going on? I mean, you look at quantum mechanics, and they want to talk about things like uncertainty principles. Maybe it's just very useful. Maybe there is some sort of weird inbuilt uncertainty into things. I don't know, and I don't know the answer to tell you on that. I personally stick with the opinion that if it's useful, you use it. And there is really no way we could ever know if we were actually describing what was there. Okay? And then they get into crazy things like the mini worlds and stuff like that. Those are always fun where, oh, let's explain it with this. Well, okay, we can't even test that, so I'll get to that more later. And that's this part. Can science models answer everything? All right? I've heard people say, well, we've got basically everything figured out now. There's just a couple little things. Of course, this is something scientists have said in the past. In the late 19th century, there were really only two things left for science or for physics to figure out, and it was referred to then as a dead subject. Right? One was black body radiation. It just was not matching up with what classical physics was saying. And the other was this newfound consistency of the speed of light, which if you've come to my relativity talks, you've heard about. Okay? And it was just those two little problems. Physics is dead then at this point. We know it all. Except the solution to black body radiation gave us quantum mechanics, which was a huge revolution in physics. And the solution for the consistency of the speed of light gave us special and general relativities, which was another huge revolution in all of our understanding of science and everything we thought we knew. So it might be a little dangerous to come along and say, oh yeah, we've got this figured out, we know, right? I mean, you might miss something too. If you're so convinced that everything that's been done so far is right, and you're not questioning it, then maybe we're down the wrong path and no one ever questions it and we don't realize it. And there was a better path we could have taken. So you can't question everything constantly. There has to be a line there, because if you just question everything nonstop, then you don't make any progress. You just stay on questioning everything. But I would suggest that always have that in the back of your mind, that if you find a result that doesn't fit with something, it might be because your assumption was wrong, even if it was a long-standing one. In fact, this kind of thinking got Einstein in trouble. When he graduated, none of his professors liked him because he questioned so much of what they said. They wouldn't write him recommendations. He couldn't get a job. He ended up just working as a patent clerk, where he wrote papers that were referred to as Einstein's miracle year. So when he came up with special relativity, E equals mc squared, and all these great things that went right against what everybody thought. There was a lady named Emily de Châtelet who went against Newton. And people said, no, don't go against the great Newton. Whatever Newton says is right. Everybody trusted what he said. Turned out she was right, not him. He had a mistake in kinetic energy. So you have to be careful with this kind of thing. So is it safe right now to say that we have almost everything figured out? I don't think so. I think that at any moment, we could find out we were totally wrong. To me, saying that you think we have everything figured out is like being in a maze. And you have no idea how big this maze is. This maze could be the size of Lakeland. It could be the size of Florida. It could be the size of the entire planet Earth. It could be the size of the entire universe. And then you make the statement, we have almost gotten everything figured out, we're right. To me, that's like saying, I'm in an unknown size maze. I have no idea how big it is, but I haven't made a wrong turn in a while, so I'm certain I'm near the end. At any moment, you could hit a dead end, and suddenly we could just start failing to explain all sorts of stuff that we were seeing that we just hadn't seen before. All right? We may come to a dead end, we have no way around, and we have to go all the way back to the beginning and start over, or else just keep hacking on fixes. This kind of thing happens, I think, a lot in physics. For example, you have the Big Bang Theory. And one of the biggest pieces of evidence to support the Big Bang Theory was the microwave background radiation. And so everybody's like, oh look, we found this. It's proof the Big Bang Theory, the Big Bang happened. Until someone realized that it didn't match with what the Big Bang should have happened. That microwave background radiation is also the biggest flaw in the Big Bang Theory. It is in thermal equilibrium, which should not be possible. So rather than coming up with a new model or accepting other things like that, they try to just hack on a quick little fix right at the beginning of the universe to say, oh, well, it must have happened like this right at the beginning, allowed this thermal equilibrium to happen, and then the rules of physics suddenly kicked in. But prior to that, we just kind of ignored it for a few microseconds or something. All right? So you have to be careful with that kind of stuff. When do we start over? You know, do we have a better theory than evolution? I don't know. Is there a better idea? I don't know. If I could think of one, I'd probably go publish it and just say, hey, here you go. But just because no one's thought of it yet doesn't mean one doesn't exist. Just because no one's found the flaw in it doesn't mean it's not there. Okay? And in fact, I go so far with my students to typically outlaw the use of the words proven and fact. If you start thinking of things as proven and thinking of things as facts, then you're never going to question them, and you get them accepted in your head, and it's very hard to turn away from it. It's very hard to change your mind once you've made it up and you've convinced yourself something is true. Right? It's a proven fact the universe is 13.8 billion years old. Well, then no matter what comes along, you're never going to question that part of it. When questioning that part of it might be the answer. So be very careful with that kind of stuff. And you also have to be very careful when people tell you, this is what science says. I don't think it does. I don't think science says anything. I think scientists say things. Scientists make interpretations. The same scientists all look at the same data. And again, I'm going back to my big example of quantum mechanics. And they come up with bunches of different explanations for why we see what we see. Is it a collapse of the waves function? Is it multiverses popping up? Is it some sort of expansion theory? Is it pilot wave theory? There's all these different ideas, all looking at the exact same results, all looking at the exact same things, and they say, well, no, this is it. This is how the universe is. I think that's a very dangerous thing to do. I think if you get so set that you are correct and that this one thing is correct, then you stop doing science. And that's not a good way to be. You're supposed to question things. All right? And the next part is, do we have to use science to answer everything? This was John Lennox's example of asking the question to explain modern cars. And there were some nice pictures here with this one too. All right? You could start talking about some internal combustion, some thermodynamics, mechanics, entropy, gears, all this kind of stuff, and stay purely scientifically. But there's another explanation, and that's Henry Ford. Henry Ford, explaining cars with him is not scientific. That's explaining it with, there was a mind behind it. Just because there was a mind behind it doesn't mean that there is not a scientific explanation that goes along with it well. They are not mutually exclusive. The explanation of Henry Ford and the assembly line and industrialization, I think they're just as valid to explain modern cars as all the physics that goes into it. Right? Having a designer does not diminish those rules at all. If you have a book, someone wrote that book, it doesn't diminish the book, right? So I guess actually what I was thinking about there is whenever people refer to it as God of the gaps. We heard that term before? The idea that whenever we can't explain anything, we just say, oh, well, God does it. We couldn't explain lightning, so, God did it. And then we come up with another explanation. Well, it's separation of charges and all this kind of stuff. Well, that's great. That doesn't get rid of the argument that God did it. Right? Assumptions. Axioms and postulates. My argument is there is not a single science or mathematics that is assumption-free. At the foundation of math, we call them axioms. At the foundations of science, we call them postulates. But they just tend to be things that we look at. They appear to be true to us, at least in our short time that we've looked at them, and we stick with them. And then anything that logically follows from that, we say, all right, well, that must be true. Well, in mathematics, there's literally an infinite number of axioms we could come up with. Who's to say we have the right ones? I mean, how many maths can we build if we have infinite selections? Maybe there's ones out there better than what we have. Don't get me wrong, the math we have is very useful. We've come very far with it, but that doesn't mean it is the way. it is the only math that would work. Okay? If I knew a better math, again, I'd go publish it. But I don't, but that's still. My lack of ability to come up with this doesn't mean it's not there somehow. Someone smarter may come along one day and just say, you know what, we made this huge flaw in the foundation of math, we should do this. And suddenly, all the things that we find so difficult to do mathematically become simple. I have no idea. That'd be great. It'd be great if I did it. It's not gonna happen. I'm not that smart, but, you know. Same thing with the physics assumptions, the postulates. We make these assumptions and we say, all right, well, it's true everywhere in the universe. We haven't looked everywhere in the universe. We haven't been everywhere in the universe. There could be something so fundamentally different about the universe outside our solar system that we just have no idea what we're looking at. And we're just assuming it's the same that is here. And that is an assumption. We look at the speed of light and we say, hey, we've been measuring the speed of light for this many number of years, very accurately, not even for that many large number of years. And we say, look, it's always the same here. And we assume that it must have always been the same everywhere in the universe throughout all time. But it's an assumption. It's like that old example of going out to the ocean, getting a cup full of water, and then saying, look, I can look at this cup full of water and tell you everything about the ocean. You're not going to predict whales, right? So you have to be very, very careful with that. And it seems to me that when you go out and you look at something in science, and we do this, we make assumptions about things continuing the way we always see them. For example, if you walk out into the middle of the woods, not near any cities or towns or anything like that, and you come across a bowl, a very nice, perfectly beautiful bowl, you don't think, oh my goodness, look, there's no people around here. A bowl formed naturally here in the middle of the woods. Right? Because every bowl that you have ever seen come into existence had someone that made it and designed it, correct? And we give that argument, and that's a very scientific argument. There was a person there that made that bowl, and somehow they put it there or it ended up there, right? We assume a mind behind it. But we look at the universe and we don't do that. We look at these organizational structures. Well, I guess a lot of people in this room, we do that. But a lot of people don't do that. And I feel like that's not very scientific. I feel like it's a double standard. Everything we've ever seen come into existence that was organized and had functions and made purposes and things like that, right, that we've seen originally come about, we saw come from a mind, from a creator of it, from an inventor. But then we look at, I keep saying we, other people look at humans and they say, well, no, that one just happened by accident. That one doesn't make sense to me either. We're not applying the rules of science to that question anymore. That just becomes an opinion, a desire, rather than an actual scientific argument. Okay? And I don't know if my video's here. Oh, there it is. Who thought this was coming today? So, we're picking up here where all of Christopher Robin's friends in the 100-acre wood are trying to save him from an evil creature called the Baxen. And they've dug a pit to trap him in it. And they've all found themselves stuck down in the bottom of the pit, except for Piglet. And they're trying to, at this point, convince Piglet to go save them, to get Christopher Robin's help, essentially. So let's see this.
Go to Christopher Robin's house.
Oh, I see. Yes, Piglet. Go and bring some honey.
Yes, bring some honey. Oh, the jump rope, Piglet, the jump rope.
With a little honey on the side.
All by myself. Yes, Piglet. Through a dark wood fraught with peril, on a mission of life or death. It is a task of great complexity, but I have full confidence that you shall return victorious and rescue us from the abyss. Go forth, Piglet, and we shall await your return, for weeks if necessary. What?
I can't believe how wonderful that speech was.
All right. So that's the question. Are we Owl? Owl is the smartest one in the 100-acre wood. He's the one they always look to. None of them can find any flaws in his logic. I mean, we're sitting here, we look at that and we say, well, it's glaring, right? He can fly right out of there. But there could be very glaring mistakes in our logic, in our thinking, that we just don't see. We could be Owl. We could be worse. We could be Piglet or Pooh or any of them. And we're all just following Owl thinking, oh yeah, there's no flaw in what they're saying. But again, just because we don't see the flaw doesn't mean it's not there. And here, I think this is my ending here. I'm trying to get through this fast so we can have some questions. And anybody wants me to go back to any of these, I could spend an hour on any one of these slides, probably jabbering about it. And that's trusting our own thoughts. If we were looking at this through a naturalist view, where everything just happens on its own, I don't see how you could ever trust your own thoughts. Ultimately, any thought you ever have is just some predetermined random event. We have no way to argue if we are rational or not. How could you trust any thought you have, no matter how logical you thought it was? We have no way to know if we're even close to being Owl or we're way worse, if it's just purely naturalistically. However, we have God. And I don't think having God tells us necessarily how close to or far from Owl we are. But in the naturalist view, we have no way at all to even hope that we could even be Owl. At least in the creation view, I believe God gave us the ability to be rational. Do I think we're perfectly rational and logical? Probably not even close. If we compare ourselves to God, we probably have no idea what true logic really is. People often ask that question, well, if God can do anything, can he make a rock so heavy that he can't lift it? The answer I want to give to that mostly is sure, yes. Someone says, well, then that's logically inconsistent. And I think, well, maybe to us. Maybe we're just not the right kind of logically, capable as everybody else or as God is. And that it is perfectly fine for him to do that. Without God, though, we have nothing to trust. You have a bunch of random processes going off in your head that are brought about by other external random events that occurred. And it's all just chemistry, and physics, and particles bumping around. I don't know. I don't really like that explanation at all because we get nowhere with it. And then I think actually this is my last one. It was 11 of them, wasn't it? So, extraordinary claims require extraordinary evidence. I have heard this one quite often used as an argument against God. When you're claiming God is there, you must have extraordinary evidence for this. Because that's an extraordinary claim. Yet, I find that this, again, is something that is not typically turned inward by the scientists. I see scientists making claims about multiple universes and infinite numbers of universes and ever-expanding universes and all these kinds of things that seem to me to be quite extraordinary. String theory, all kinds of them, which even gets the name theory, despite not making one single testable prediction. All right? Why don't they turn this on themselves? Look within it. These extraordinary claims, do they have extraordinary evidence for this? We're making the extraordinary claim that there was absolutely nothing, no time, no anything, and everything just popped into existence for no cause whatsoever. That seems to me to be a very extraordinary claim. I feel like you need evidence for that. I don't think we have evidence for that. Quantum mechanics gives us this uncertainty principle. One of the explanations is that, because they didn't like this was originally, the Copenhagen interpretation was, we had this uncertainty. And then when you made a measurement, we as people took a measurement, it actually forced nature to choose randomly where something would be or what the outcome of it would be. All right? Erwin Schrodinger gave his famous Schrodinger's cat experiment, and a lot of people use it to explain quantum mechanics. He actually intended that as a way to explain how absurd quantum mechanics was. Because at the time they were saying quantum mechanics, well, it's not a big deal, it's only weird and uncertain on a small scale. And he was trying to show how you could take that small quantum uncertainty and have it be a very big uncertainty in the real world. And how absurd that idea was. And so you had the Copenhagen, it just actually collapses down and is in one point. Which seems to be what we see. You go in, you take a measurement, and you get a single result out. They did not like this, because then people started saying, well, look at that, who's making that choice of where it is? Oh, it might be God. So they switched it over to the many worlds idea, which is that you have all these possibilities, and when an action occurs, when there's a measurement making, it isn't that just one is chosen and occurs, they all occur. And so for everything that happens, you get, for every possible outcome, you have a version of the universe where that happens. I'm not sure they have evidence for this whatsoever. They'll even tell you there's no way to test for this. But yet, it's all over movies. It's everywhere, the multiverse. We see it all the time. All right? I don't know. That to me seems like something that needs extraordinary evidence, not just a speculation to get by it. Besides, one of the things that always bothered me is they only ever give the example of 50-50 chances. This could have been an upspin electron or a downspin electron. And so we have one universe that's up and one that's down, it's 50-50. What happens if it's 70-30? Do we get 7 universes where it was one way and 3 where it was the other? Or 70 and 3? Or 0.7 of a universe and 0.3 of a universe? I don't quite know how to wrap my mind around that. Because in quantum, most of the probabilities are not equal. They're all over the place. That's the special case when they're equal 50-50 like that. All right? Lastly, people will make the claim that they want extraordinary evidence for God. But my question is, would they accept it? And there's 2 fronts on this. One, I have found that most times when you're speaking with someone who is an atheist, that you can ask them the simple question of, what evidence would it take for you? And they say, I don't know. So I often offer, let's pretend you're out one day, and the skies opened up, and God came down and called you out by name and said, I am here, I am real, believe in me. My next question to them, they said, okay. I said, so the next thing is, are you running to a doctor because you're hallucinating, or are you running to a church? I have yet to have an atheist tell me they're running to a church. They're all running to a doctor. I don't think there is any evidence that can exist for them. Perhaps God put some sort of, let's say he did something where he put something absolutely incontrovertible. He put something there that disobeys all the known laws of physics. Say, I don't know, a pillar of fire that can never be put out and is just sitting somewhere, floating. Would we look at that and say, look at that, that shows us God exists? Or would we come along and try and come up with physical laws of nature that would explain it? Would we even notice if there was something that absolutely was incontrovertible evidence for God that he put in there? My argument would say, we have that stuff already, and we just don't recognize it, or we refuse to recognize it. We instead try to come up with other explanations. Pretty sure that's the end here. We'll know, I think, if this next one is toothbrushes. Or it's just blank, actually. So yes, hey, that's right, all my images were gone.
Why toothbrushes?
I don't know. It happened to be on the theme, I think, and it was like one of the pages that I didn't delete off the end. which I probably should have, but I kept thinking, well, what if I decide I want to use that and add one in at the last minute, and I didn't. And I didn't want to delete any of the other like little formatted pages. Thanks for asking that.
Of course.
All right. Any questions? My main goal here, hopefully, was to get y'all to maybe think about some stuff. If I'm wrong about anything, boy, I want to know it. You know, even if you don't want to ask me a question here today, and you see me around on campus, come talk to me about it. I'll sit down and have lunch with you. You know, I love talking about this stuff, so let's go for it. Yeah?
I teach middle school science, and one of the things we start out with at the start of every year is nature of science. So I show my kids a video of Galileo and how he challenged the church prescribed theories of geocentrism and heliocentrism, and how he did heavier objects and faster objects by dropping an orange in a grape, and how they didn't believe it even when they saw it. So that goes back to your atheist thing, is even these Catholic cardinals wouldn't believe it when they saw it in front of their own eyes, and said, oh, I don't see the need to drop fruit on the table to prove a point. So my question is, today, without naming any names, when we have scientists that kind of place themselves above everything and say, this is the science, this is the settled science, how do you go about questioning that when you can lose your job for it? And
Oh, gosh.
it's actually something.
Well, anyway, I think we're about out of time here. So, you know, I can tell you, if there's no threat of losing your job, I know what I would do, and I would give them a lot of these arguments I gave today. I don't know if it was a good idea or not, but it was at the, I guess, the urging of my father once, where I had a professor tell me that something was a fact, and I got in an argument with him. I said, that's not scientific, you should not say that. Okay, so I would discuss it with him. I don't think you should start yelling at people. I don't like arguments. I like discussions. Discuss things with them. You should listen to their side, definitely. You know, they have that whole kick of being open-minded. I don't mean it the same way as most people nowadays, where they say be open-minded, and what they mean is, you know, listen to me and accept what I'm saying. I'm saying be open-minded and actually consider stuff, but just because you consider it and think it through doesn't mean you have to accept it.
Yeah, because they destroyed Galileo for his beliefs, and but the funny thing is, his beliefs still got out because they smuggled all his writings out. So I guess at some point, if you really want to change something, you kind of have to take the fall, don't you?
Yeah, but you know, they're people too. You know, all the sides are kind of guilty of doing that, aren't they? You get, which is what I was saying, you get stuck in your way of thinking that this is the way it is, and you just, no matter what evidence comes along to the contrary, you are unwilling to change. See that a lot. I see that on you know, not just in the scientists, but you see that in some religious people as well. Quite a lot. We're humans, right? We're not perfect. So we gotta not expect that the stuff we do is also perfect. Yeah, maybe.
Can we use all this against ourselves too, as a creationism as well?
You can.
Yeah. How we like?
Well, I struggled with that for a long time. And what I ultimately realized, and I guess we kind of go back to, I think it was it Descartes that said, I think therefore I am, kind of an idea of the only thing I can really know, was that him? No, Descartes wasn't that. Who was that said that? Was it? Oh, okay, well then I'm not crazy. I thought someone was shaking their head at me and made me doubt it. But I've come to the conclusion that a long time ago that really the only thing I can know is that I somehow exist. I don't necessarily know what form I exist in. I don't know that I'm necessarily a person, and I don't necessarily know that the rest of y'all exist. But I believe you do. I believe it. And at some point, you do have to take a belief in something. One of the big things that drives me to thinking that I am not just the only thing in existence, and I am the only conscious thing, and the rest of you just appear that way, is that I'm not smart enough to dream up all of you. There's no way this could all be in my imagination. I'm not creative enough. I'm not smart enough for any of that kind of stuff. So I know that there are limits to my intelligence, and I accept that. And I guess one of the things I've also realized is that the more I've ever learned about something, the more I realize how clueless I am about it. And I get to be so clueless, like you get a surface level. I remember I took general physics and boy, did I think I knew physics. Oh yeah, and then I got into those later classes where they were asking me questions that I never even occurred to me to ask and didn't know I didn't know. So I guess one of the biggest ways that if I turn this in on myself is I just know I'm not smart enough to do this on my own. So I have a choice. I can choose to put faith in myself, which throughout my experience of my life is not warranted, because I have made lots of mistakes and I've done lots of things wrong and I've gotten lots of things wrong and there's lots of things I don't understand. Or I choose to put my faith in God. And that's where I go, because ultimately it is a choice. Just like for the atheist, that big piece of evidence comes down. Do they choose to go to a doctor for help and just, I must be hallucinating? Or do they choose to say, well, God must exist, I better start believing in him? That's the best I can do on that one.
So we could, technically you got to be skeptical about God too as well, as something I'm saying. It's like, you could fall over the place.
It's faith.
Yeah.
It is faith. It can go around all the time. Because, again, what can we really know? We're in that big giant maze. We have no idea where we are in it. And even if we get to a point where we think, man, we can explain everything we've ever been able to see, there's still always that one thing that could just come along at any moment that says, hey, guess what? We can't explain this anymore. We maybe explain absolutely everything we could ever see for hundreds of years, and we think, man, we've got it down. And then it turns out, guess what? Something came along, someone figured something out, and we're like, wait, we can't explain that anymore. So, no, good question though. But yes, you can apply that to that argument, which is why we have faith. It is a choice, right? Free will, right? Oh yes, go ahead.
Sorry. So one thing I struggle with every year, I teach in public schools, so obviously you have separation of church and state, and I teach middle school science. So one of the standards we have to teach is evolution. And there's microevolution and macroevolution, and one of the macroevolutions that we have to teach, one of the standards is walking whales. Whales coming from Taxitus and going through all the things and using the toe bones as evidence for evolution. That's kind of a sticky standard for me, because I have to be very careful about how I tread around there being a higher creation behind the reason for these evolutions. How would you go about teaching that in a way that doesn't contradict?
So, I actually do have a way I do that. And that is by very early on pointing out that these are hypotheses and theories, and they are not facts.
What I did.
And I will tell you, I am teaching you the current hypothesis and standard. That doesn't mean that 100 years from now, someone won't have a much better idea. Someone comes along right now and says, hey, look, this idea of evolution is terrible, and then in 100 years from now, they look back at us and laugh and say, look how stupid were they thought this was the case, but it was actually this. Like the Greeks that thought light came from their eyes. We look at that and we think, well, that's silly, but they had evidence, right? You open your eyes, you can see, you close your eyes, you can't. But now we look at it and we're like, no, that's silly. Because what about at nighttime? You open your eyes and you can't see.
Yeah, that's how I
So,
start. I tell them, look, we're discussing this is a scientific theory of evolution. So I know some of you may go to church. We're not discussing creationism versus evolution here. This is the theory. I guess what I can do is try to point to some of the things like the scales on a butterfly's wing. Some things are so intricately designed that how could it be random chance?
Yep, I would do that, and I would just really make sure they know that 100 years from now, we could all be being laughed at for having thought what we think and being so certain of these things. Anybody else? I'm in my acting. Oh yes, go ahead.
So this is kind of out there, but as a Christian and a physicist, how do you argue against outlandish claims like flat Earth or the simulation theory, things like that?
How do I argue against them?
Right, because I know in our physics class we have
because you
flat
remember
Earth.
when I argued for the flat Earth in class.
I will not forget.
I knew that was going to come back to haunt me one day. I don't know that I argue against them. I'm not sure there's anything incompatible with them so much in Christianity. saying we're a computed universe, I don't know, are we? I mean, maybe we're computed in God's mind or something. Like, I don't really understand God well enough to argue against those. I don't know, or do I think I ever could possibly understand how he made us, how he gives us this reality, what's it sustained on. So I don't think I would argue against those. Not in a Christian standpoint necessarily.
To be clear, you're saying flat Earth is a possibility?
I don't know, can we disprove anything? Because then we have to prove it completely wrong. And we've had things, for example, and I'm not saying I necessarily believe in flat Earth, don't get me wrong on this, but just to go in on this one, let's think of Einstein's cosmological constant. This was an anti-gravitational force that he had built into his original equations for general relativity. And then Hubble came along and disproved it. Okay, it was disproven. He took it back, pulled it out of his equations, called it his greatest blunder. About 80 years after he died, they started finding that actually what we're seeing now is explained if you add that back in. So even something that gets disproven can later come back with new information, and someone says, hey, look, we discovered this new little bit about this. This actually over here wasn't such a bad idea. Maybe we shouldn't have thrown it away. So stuff that gets disproven doesn't stay disproven. So
We've got satellites now, though.
what's that?
We've got satellites now.
We do.
So that's a big
We do.
thing. We need to use technology to also explain phenomena that is actually supported by evidence.
I didn't say I could support an evidence of a flat Earth. I'm
No, but that's what
I'm
I'm
just not
saying is
claiming to be
I think it's not-
omnipotent enough to know for certain.
Yeah, but that's the point. It's like, okay, we don't have to go into the argument of it, it just
Right.
shows evidence.
If
Just
you
like
have
how
evidence to
Hubble
back it up,
actually
then-
proved it out. So,
If you have evidence and it backs it up and it's useful, maybe I should clarify this. I am on the side for science of if it's useful, use it. That's what it's good for. I don't think we're necessarily discovering something fundamental about the universe. And if we are, does it really matter? Can we ever really know? I don't think so. I think it just has to be useful. If it's useful, it gives us predictions and we can use it, then it's right.
so I think that the take home is, especially for scientists, is to accept the fact that nothing is absolute.
There you go.
That's essentially it, right? And it's like, and we teach our kids that every single time. There's nothing absolute in science. That's why we don't say it's a fact all the time.
It's the only
because
fact
it
in science,
changes.
right? I like that you said that.
Exactly.
The fact of science
But-
is that
but I
there's no
think-
facts.
But I think the important take home is that you've got to pursue to get more and more facts and not just land on it and say, well, that's it. That's the whole point, is to get a better understanding. Is it really flat? Is it really round? And that's why we got all these computations
Yeah.
around us, thanks to physics, right? And thanks to biology to see the distribution of where organisms are. And so I think at the end of the day, you've got to look at everything not in one lens of science, but rather in everything and put it all together so that physics and chemistry and biology actually make sense.
Well said. Usually people are much more eloquent than me, as is just shown right now. Anything else? Could I have talked for another 6 minutes? Yeah.
Would you describe the desire to know everything part of the human condition? Because if you go back to the Garden of Eden, that's what they were promised to when they're given the option of taking knowledge of good and evil. And then also going along with that, on Mount Sinai, they experienced all these amazing things that God did, and when Moses went up, they didn't know something for sure, so they reverted back to making Baal.
Yeah, I think in some people more than others, right? Some people really want to know everything. And some people are kind of like my poor wife here, who's like, yeah, I don't really care that much. Just move on, this is not that interesting. So I think we of course have that to some extent, and probably much more in some people than in others, that we would want to do that. I apparently have that very much. I can't stand not knowing how something works. I want to. Even if I think of it just a model, I still want to know how the model works. I still want to know it. I like being able to explain stuff. And that's also one of the things I've had to accept in physics is that I have to just enjoy trying to figure stuff out because I know that I never really truly can. And I can never really truly get to the end of that journey. So I have to be content just with the journey. I don't know if that totally answers
I get it, because like the more knowledge you know, the more you understand that you don't know everything.
Yes, and that's what I have found. The more I know, the more I realize I don't know anything. Yes?
Piggybacking off what he said, that brought to mind an argument that I think maybe an atheist might have about the Garden of Eden thing. Like, oh, why, if they say to you, why would God not want you to know the difference between good and evil? Like, was God hiding things from them, and that tree gave them knowledge, so why would God hide knowledge from people? Was he afraid they were too naive to handle that there's evil? So.
Do you want my opinion on that? I mean, I'm not like a great theologian or anything, but I think the only way I explain that is just choice. You know, that tree was there to give us a choice. That's our free will right there. Right? If that tree isn't there, then we don't really have a choice to either choose to love God or not.
They gave us the choice to, you want to do things on your own? There's a way out.
Yep.
Do you think that the rate of discovery is predetermined?
What do you mean by that?
Like, do you think that we're only going to be able to discover in science as much as like God has already predetermined for us, or do you think there's more like within our control over like the timeliness of discovery?
I can't say I've ever thought of that. I can't say I've ever thought through that one. I don't know. I don't know. I feel like you're asking me to pick my theological, like, am I a Calvinist or? I don't really know on that one. That's kind of a totally different discussion that I wasn't really looking forward to getting into in front of a whole room full of people. But if you want to come to a lunch with us math professor sometime on one of those Wednesdays, I'll talk to you about it then.
He will.
Yes, endlessly and happily. So, and I know you know, a lot of us would. We like that kind of stuff. So, yeah, I don't know. I wasn't quite prepared for that question, or willing to step out on that question. Okay. Anybody else? Yes.
Going back to what Mark was talking about, do you actually think, so like we're talking about science is to be useful, and if it's useful, we use it. Like, do you think it would actually even be helpful to understand like the fundamental truths of the universe, or like aside from its use, or does it really not make that much?
I think it'd be great and useful, and I would love to know it.
Me too.
But I don't know that it's. I said so. Even if we did somehow figure it out, how could we ever be sure that we had? I guess.
If there was a way, like, would it actually even? Like,
Sure.
Because we like.
Maybe it'd give us a lot more advances over everything else we've done. I mean, there's all kinds of benefits of that. You know, we could find out what we were thinking of all this stuff wrong, and there's much simpler ways to do it. You go into quantum mechanics, and there's like 2 or 3 or 4 problems that you can solve exactly. Right? The rest we do by approximations because we are not good enough at the math. Does that mean that there's a flaw in quantum mechanics? Does that mean we're just not smart enough? Or does that mean that, you know, we're coming about it the whole wrong mathematical way? I don't know. And if we knew the actual truth of it, we could come about it in the proper way and make the calculations easier. Maybe we wouldn't have to approximate anything anymore. I can't imagine the universe is going around making these same approximations that we have to. So to me, that screams there's something wrong. I feel like it should be easier than it is. Maybe there's people who are way smarter than me that already think it's super easy, so they don't have the same objection. But I feel like it should be easier than it is. If I want to throw something into that basket over there, in that waste basket, I don't have to. You know, I kind of feel it in my hand real quick, and then based on just my experiences, you know, a lot of times I can make that. Okay. I would say 99 out of 100, not to brag or anything, but I'm not sitting there doing any calculations. I'm not calculating out what angle to throw it at, how hard to throw it, what the wind resistance will be, or anything like that. That just comes very naturally to us. You know, you can kind of learn to do that on your own. But if we sit down with a piece of paper, that's kind of a long problem.
Yeah.
Isn't it? I mean, whoever did projectile motion with me knows.
I was just about to say.
Right?
That process of like breaking the leg thing. I was like, this is ridiculous.
They're tricky, and those are actually easy problems comparatively. You get into more complex mechanics, and you start talking about Coriolis effects and stuff of rotating coordinate systems, and you're like, please let me go back to the projectile. You know, that only took me 2 pages to figure out. This one's taking me 40. You know, so I don't know. I think maybe if we could, it would make us easier. I'd love to know it. But again, if we did know it, I'm still not sure how you could ever know for certain that you did know the actual answer. So yeah, I still want to advance it. I want it to become easier and easier. And I think I need to be quiet now, because I just noticed it's 11:01. So thank y'all very much.
Math students and guests and visitors can stay in this room. All of the science faculty and science alumni are going to meet outside this building, outside our front entrance, right now.